Have you ever wondered how our bodies fight off diseases and infections? Well, it's all thanks to a complex yet efficient system called immunity. Our immune system, much like a vigilant sentry, is always on the lookout for invaders, ready to defend us from all sorts of foreign substances that could potentially harm us. So, what is immunity, you ask? It's our body's innate ability to resist harmful microorganisms from entering it, or to destroy them once they've made their way in. There are two main types of immunity that work hand in hand: innate and adaptive. Innate immunity, as the name suggests, is our inborn defense mechanism. It's our first line of defense against pathogens, like bacteria and viruses. It acts quickly, often within minutes, to fend off invaders. But it's not very specific. It treats all invaders as equal threats. On the other hand, we have adaptive immunity, which is like a specialized SWAT team. It's slower to respond than the innate immunity, but it's highly specific and has a memory. Once it has encountered a particular pathogen, it remembers it. And if the same pathogen tries to invade again, the adaptive immunity responds more rapidly and effectively. Now let's talk about the soldiers of our immune system: antibodies and immune cells. Antibodies are proteins that recognize and bind to specific parts of the pathogen, effectively neutralizing it. Immune cells, on the other hand, are like the infantry. They're involved in both innate and adaptive immunity, acting to destroy the invaders or to stimulate other immune responses. In essence, our immune system is an intricate defense mechanism, always on guard to protect us. It's an incredible system of checks and balances, of attackers and defenders all working together to keep us healthy. But how can we enhance this system? That's where vaccines come in. And we'll delve into that in our next segment. Stay tuned. Now, you might ask, where do vaccines come into the picture? Well, let's dive right into that. Picture vaccines as a sort of dress rehearsal for your immune system. They're like actors playing the part of harmful invaders, teaching your body how to react when the real deal shows up. But don't worry, these actors aren't the kind to go off script and cause a real infection. Vaccines are developed by taking a tiny piece of the virus or bacteria, such as a protein, or weakened or inactivated versions of the agent itself. This part is crucial, as these components are harmless on their own, but they're enough to make your immune system sit up and take notice. Upon receiving a vaccine, your immune system kicks into high gear. It recognizes these foreign invaders, even if they're just playing pretend, and mounts a defense. This defense includes producing cells that remember these invaders, aptly named memory cells. Now here's where the magic happens. If you're ever exposed to the real virus or bacteria in the future, these memory cells are ready and waiting. They remember the invader from the vaccine and quickly stimulate your immune system to fight off the infection. It's like having an elite, specialized force within your body, ready to protect you at a moment's notice. This process of teaching your body to recognize and combat specific viruses and bacteria is what we call establishing immunity. It's a crucial part of how vaccines work, and it's what keeps you safe from many dangerous diseases. But remember, vaccines aren't just about protecting individuals. When enough people are vaccinated, we can achieve what's known as herd immunity. This means even those who can't get vaccinated, like babies or people with certain health conditions, are protected because the disease has nowhere to spread. Vaccines, therefore, are like a training course for our immune system, preparing it to fight off infections effectively. They're our body's secret weapon, a testament to the power of science and our best defense in the ongoing battle against infectious diseases. But how long does this immunity last? And how can we know if we're protected? These are questions that often arise when discussing vaccines and immunity. Let's start with the duration of immunity. Vaccine-induced immunity duration varies depending on the disease and the vaccine. For some diseases, vaccines provide lifelong immunity. For instance, 2 doses of measles vaccine in childhood can provide you with protection for the rest of your life. On the other hand, some vaccines may require booster shots over time to maintain their efficacy. Take the tetanus vaccine, for example. After the initial series of vaccinations, adults typically need a booster shot every 10 years. This variation is due to the different ways our immune systems interact with different pathogens, and how vaccines mimic these interactions. The key takeaway here is that vaccination schedules are designed based on rigorous scientific research to ensure long-term protection. Now, let's move on to antibody testing. Antibodies are proteins produced by our immune system to fight off infections. They're like our body's soldiers, ready to combat invading pathogens. Antibody testing is a method used to measure the presence and amount of these antibodies in our blood. This can give us an indication of our body's immune response to a specific pathogen, whether from natural infection or vaccination. However, It's important to note that having antibodies doesn't always equate to being immune. Some people with low antibody levels might still be protected, while others with high levels might not be. That's because immunity doesn't solely rely on antibodies. There are other components of our immune system at play, such as T cells, which can remember past infections and trigger a rapid response. Moreover, not all antibody tests are created equal. Some might detect antibodies that don't actually provide protection against a disease. Therefore, the results of an antibody test should always be interpreted in context, often by a healthcare professional. Antibody testing can help us understand our level of protection, but remember, it's just one piece of the immunity puzzle. So, now that we've learned about immunity and vaccines, what can we do with this knowledge? Well, the first step is to share this information. Knowledge is power, and it's this power that can help us protect our health and the health of those around us. Remember, vaccines don't just protect us as individuals, they contribute to what's known as herd immunity. This means that when a large portion of a community is vaccinated, the spread of harmful diseases is inhibited. This helps protect people who, for various reasons, might not be able to get vaccinated themselves. So, sharing what you've learned today can have a broader impact than you might think. It can help dispel myths about vaccines, encourage others to get vaccinated, and contribute to the overall health of your community. But sharing this knowledge is just the first step. We also need to advocate for vaccination. This means speaking up about the importance of vaccines, supporting policies that encourage vaccination, and standing against misinformation that can lead to vaccine hesitancy. Vaccination is one of the most effective tools we have in preventing disease outbreaks. It's helped us eradicate diseases that once claimed countless lives, and it's our best defense against new threats. But vaccines can only do their job if people choose to get them. Lastly, remember that while advocating for vaccination, it's essential to respect others' perspectives. Conversations about vaccines can be fraught, but they're also an opportunity for education and understanding. So, approach these discussions with patience, empathy, and respect. In conclusion, the knowledge we've gained today about immunity and vaccines is not just for ourselves. It's a tool we can use to help create a healthier world. It's a call to action. It's up to each one of us to share this knowledge, advocate for vaccination, and contribute to a healthier community. Together, we can make a difference.